So for the normal basic 3D model printing, go to that model and then it will bring you to this screen where if you look on the left hand side, 1, 2, 3, 4, 5, 6, 6 different steps that you need to complete for the on this like a form that you fill here on the software, and the printer will start printing. So the first question that the software asks you is where you want to print. So for BioX, one thing I didn't mention just now is this is an open system. So that means it doesn't have to use our consumables. It doesn't have to use our material. You have your own material. You have your own whatever surface. You can put it there. It will print. Yeah, so this is the platform. Anything you can fit over here, it will be able to print on top. So of course, in this case, it asks us to choose what kind of surface that we want to print. By default, it will be Petri dish, but you can choose well plate as well. And when you select well plate, you can have 6 well plate all the way to 3A4 well plate. As long as your 3D model can fit within the well, it will print it for you. Alright. So for demo purpose, I will go to the surface. So that is the first question, where you want to print. The second question is what you want to print. So you have to input the 3D model. We provide some simple STL file in the USB that come with it. So if you have your own USB, you are also, if you want to fill in, you can also, through the USB, you can put in your STL, and you can actually ask them to like select, and it will showcase your model over here where it will print. Of course, even you have the STL, the structure is already fixed. This one allow you to further transform the structure you want. For example, you can make it bigger. You can, if you don't want to lock, you just want the Y to be bigger, it can be done. So you can have a minor adjustment of your structure over here if you like. Alright. And that is the second question that you answer. So what is the model you want to print? And then the third step is the printer will do the slicing for you that means divide your structure into multiple layers. And how thick is the layers, that is decided by you. So in this case, we are going to use this blue nozzle. This is what we call a nozzle, blue nozzle. We also have blue needle, but the blue doesn't just means color. It actually have a special grade here, the gauge. So 22 gauge, we call it the gauge. 22 gauge correspond to the internal diameter of the filament that you're gonna come out. Okay, so for these two blue, one is needle, one is nozzle. These are 22 gauge, which is equivalent to 0.41 mm diameter. Alright, so you can imagine out diameter, if it come out, the filament will be with a diameter 0.41. It will land on the Petri dish, and that will be your thickness height. The 0.41 will be 1 layer height. Alright, so this is how you select. So if you are using a blue one, or if you are using the red color one, then you need to change the layer height to match the red color nozzle. Alright, so with a different color, we have white color as well. This is 22, this is 25, this is 27 gauge. That means the higher it goes, the finer it becomes. Okay, so the finer your layer height, that means it will cut more layers for you. So the total height for this construct is 1 mm. And right now I'm dividing with a 0.41. So it will cut into 2 layers for me. 0.41 and then 0.82, and it will not go above, so it will round down. So 2 layers. If you have a layer height of 0.2, it will give you 5 layers. The more layers you get, the higher the resolution, but the slower the printing time. So this is something that give and take, is see if you want. For this one, we will stick with the default. So yeah, so it will showcase here. You can change the grid to different design that you want. You will see that it changed immediately. And you can even change the what we call the infill density. Okay, so when I change the infill density from 25 to 15, it actually make the space bigger. Of course, if you go up, then the space will become smaller. And again, with more space, then less filament. Smaller space, more filament. More filaments, also longer printing time. So these are the things that you consider. So that is the third question. When you do the slicing, what you need to consider. The fourth question is to tell the print heads what parameter you need to do to print the filament. So for this one, extrusion, there are two key parameters that will affect the filament that you generate. The first one is the pressure, how high you want your pressure to be for that material. And the second one is the printing speed. Okay, so the higher the pressure, the more material will come out, the thicker your filament will be. The lower the pressure, thinner filament that you will get. The faster the speed, the thinner the filament. The slower the speed, the thicker the filament. So these are the two parameters that you're gonna play with. Again, different material. That is the blue one. This is like a pink color hydrogel. These two material will have two different parameters to generate the same size of the filaments. Okay. So material property is the key. And for this one, since this is our training ink, I know the parameters. For the pressure, this only require 22 kilopascal. For the speed, we will stick with 10. And don't worry if you don't know what parameters of your material, you can still change it during printing. So when the printing starts and you see that, oh, the filament is ugly and you want to change, refine, you can do it real time on the software and do fine adjustment on the two parameters. And then this is just other kind of like miscellaneous setting. For this one, we'll stick to it, but this one you can actually decide what lighting that you want during the printing one, what temperature you want, whether you need photo crosslink between the printing. These are all can be set over here. There is question number 5. And last one will be the summary page. And this is where you have to, the software show you all the things that you set previously here. So now you click on go to print. This is a start print. You see, the start print doesn't light up. Why? Because you haven't tell printer one thing. You haven't tell the printer where to print. That's important. Remember, I told you you can print on a different surface. So some surface is tall. You have to tell the printer this is where you start. Some surface is lower. You have to tell the printer this is where you start. So this is what we call calibration. You have to calibrate the printer. So the first thing I click will be calibrate. And then I click on automatic bed leveling. Alright. So before the printer know the location, the printer want to make sure that it can give you a good printing, a fine printing. So he need to make sure that stage is level. I mean, to us, it is level, but to the printer, it need to even make adjustment for the tiny scale. So now we're gonna do what we call bed leveling. Alright. What you will see here is that it will do the homing, and then it will use that small stick over there, this stick over there, to take 3 points, and then from the 3 points, it will know how level this is. So once he know how level it is, when you print the construct from left to right, this will make necessary adjustment to match the thing. We do the automatic bed leveling with a petri dish to take into account the surface on the petri dish as well. But even if you want to do it without the petri dish, that's fine too. Okay, so once this is done, then you will be able to do the calibration. But now I need to put the thing on top first. Let me quickly take the nozzle. And from the nozzle, I just slot it here. So release this, and now I gotta connect this like this. So now this nozzle one is ready. Manual calibration. So So now I'm gonna do calibration and tell this to start printing on this surface. Alright? So very fast. Okay, when it's closed, change to the smaller step size. These motors here, XYZ motors, the resolution is down to 1 micron. Very small. So, but the one that you can control, the step size that you can control is 10 micron. I'm using 100 micron now. Okay, so it touch. Maybe come to the center a bit. Alright, so now this is at the surface, and then this is where I save the calibration. Alright, so now you can click start, and then you will print, the printing will start. It should follow, I think if you want to see, you see now there is a bit of a breaking over there. So if you want, okay, so you see now there is no breaking. So you can, I mean, if you don't like the previous one, you can always pause, remove, and then print again. So then it will become okay. But now the printing, we just leave it is just 2 layers. So even though the first layer a bit break, second layer able to catch it, and then this is what it show. And I click. Of course, if you want to restart, you can always click restart, and then you can click start print again. So wipe, put it back, print. Then it will print the second one, the third one, and the fourth one. But the key thing here is that it has to match what you set to 2 cm, and the thickness of 1 mm. Yeah, so there is the 3D printing of using a soft material.